Thank you, everyone, for joining us for today's GSA Fleet Desktop Workshop on diesel maintenance and management. With that, I'm going to turn things over to Justin Nye.
Thank you, Stacy. Good morning, everyone. My name is Justin Nye. I'm a program analyst in our vehicle management division. I'll be presenting with John Hampson and Peter Milke today from our engineering branch on diesel maintenance and management. As Stacy mentioned, these slides are available at the GSA Fleet Training website, and we also do have a one-page recommended drivers checklist for diesel vehicles. And during the brief, as Stacy mentioned, we do have the Q&A box. We have members of our engineering branch, the maintenance control center, and an FSR available to answer your questions during the brief. And at the end, we'll try to answer some of the questions live. Our target audience today is fleets with buses and medium and heavy trucks, particularly when these vehicles operate on campus environments or have a low speed or high idle duty cycle. These use cases generally lead to more pronounced engine and exhaust issues for diesels. And for those experienced with diesels, we'll be highlighting the systems that change due to more stringent emissions requirements. The diesels of 20 years ago, they're not the same as the modern diesels. And for those interested in EVs, some people are interested in EVs going into the mediums and heavies. Today is solely focused on diesels, so that'll be covered in another brief. So our agenda for today, we'll start by discussing vehicle selection and when you may want to consider another fuel type. Then we'll compare diesel maintenance to other fuel types. We'll be highlighting the diesel particulate filter, DPF, and diesel exhaust fluid DEF systems, since these involve driver responsibilities. We'll also talk about the pros and cons of biodiesel, and we'll finish with using telematics to assist with managing diesel fleets, and we'll also quickly highlight the recommended drivers training. Now I'm going to hand it off to John Hampson to discuss vehicle selection.
Thank you, Justin. Good morning, everyone, and thanks for attending. Some of the follow-up slides will go into some more detail, but I'll just get into some of the basics here. So picking the right vehicle. And in particular here, we're talking about some of the light-duty shuttle buses, some of the vocationals, and some of the pickups, and in some cases, even some of the medium and vehicles as well. So diesel engines have always been more efficient and still are, but some of the challenges with the diesel engines are becoming a little more apparent with the exhaust treatments as of about the last 10 years or so. And we're also at a time when we have some very, very fascinating, very powerful gasoline engines. The Ford 7.3 liter is an example of a vehicle, of an engine that compares very well with diesel in a lot of cases. So regarding the efficiency, use that to your advantage. If you have a vehicle that's covering a lot of miles, in particular pulls a lot, you can take advantage of it. Also take advantage of with the higher mileage, you're also going to have higher life expectancies. And so if you're putting 20,000 miles of vehicle on a year, 30,000 miles of vehicle on a year, particularly in a bus or something like that, diesel is still the way to go. In particular, as we mentioned, we're talking to campus environments where the gasoline, in a lot of cases, is going to start making more sense. So diesel engines also offer better torque, particularly low RPM, and the turbo diesels don't have the loss in horsepower and torque as they increase in elevation. So think about your requirements for this vehicle. We tried to jot down some things here that might make sense. If you're pulling a trailer and you're pulling it up over the passes out west, or even on the East Coast in Harrisburg, Pennsylvania, or something like that, and you're pulling a lot of mountains, diesel will pull better. But these new big block gas engines like the Ford 7.3 liter, very capable, put out a lot of horsepower and pretty reasonable torque, and can really do a nice job, particularly if you're covering lower distances and less elevation, less climb. So if you're pulling trailers over the passes, yeah, you're probably just going to stick with diesel. If you're flatlands or shorter runs, campus applications, gas is going to make great sense. use the GSA Fleet Center of Expertise and vendors to help you research capabilities. And with that, I'd like to introduce Peter Mielke. For those of you who don't know Peter, he's one of our medium and heavy vehicle engineers, and really knows this commodity, knows the products. And I'm going to hand it over to Peter for some more details.
Thank you, John, very much. Appreciate it. To diesel or not to diesel, that is the question. In the past, the diesel engine was the best solution for most all applications to do with larger vehicles. In fact, in the late 1970s and early 1980s, we had a mix of gasoline and diesel engines in buses and trucks. To make them more efficient, the change to diesel was sweeping. Everything went to diesel. Now's the time to consider avoiding diesel if you can. It seems like we're turning back the clock, but as things change, we must change with them. So what are the reasons to use a diesel engine? Yes, diesel is the most efficient and power generating fuel you can find. You can always get more torque out of the same cubic inch as a diesel engine as compared to all other fuel types. And torque is what gets you moving and not horsepower. The more torque, the more weight you can move. But the applications where diesel makes sense are getting fewer and fewer. In vehicles greater than 35,000 pounds GVW, you have no choice but to use a diesel. You will need to be smart about how you handle them and not allowing the exhaust after treatment to get clogged up with ash. There will be a supply of gaseous fuel and even electric powertrains available on the market, but nothing will meet the efficiency of a diesel. If you need to run a power takeoff that operates at high speed for extended periods of time without the vehicle moving, you need a diesel engine or an auxiliary power unit. If most or all of your driving is at 40 miles per hour or better, and you do that more than 50% of the time, diesel may still be the right choice for you. If you tow a substantial trailer, let's say 20,000 pounds or more, and you tow that trailer more often than you don't, the diesel is probably the right application if that towing involves mostly highway miles. If the vehicle is under 35,000 pounds, you can actually get a gasoline engine again. Both Ford and International are offering chassis with gasoline engines for buses, as an example. I have been continually asking the other brands if they have gasoline engines in the pipeline, and so far nothing. Ford is the only company that puts a gasoline engine in a truck chassis class 6 and larger. The problem, however, with the Ford is a lack of a live PTO from the transmission. If you use a hydraulic plow and salt spreader, for example, the Ford will not continue to operate at idle. Upfitting a diesel is probably the easiest to install a body on. The only worry is the exhaust temperatures generated during active regeneration, which requires additional insulation around vulnerable parts. In 2010, the exhaust after treatment system took up valuable space under the right side of the cab. We counted on for additional fuel, location for air tanks and battery boxes. That problem has been somewhat minimized on some sizes of engine, making the SCR system much more compact. But with all the benefits of diesel, there are some severe problems with doing things the way we used to. Some old bad habits just won't go away, and the biggest one is idling. No engine should be allowed to idle more than 5 minutes without moving, but a diesel is particularly vulnerable to this bad habit. The diesel engine is basically a big air pump. To keep it simple, I will say there is no restriction to the airflow going through the engine, unlike a gasoline engine. Since there's no restriction to the airflow, the diesel only provides enough fuel to keep the engine turning, and that does not produce enough heat to keep the DPF clean. So idling, especially in cold weather, is a mistake. The more it idles, the colder it gets. If it is more efficient to shut the engine off for 10 minutes after driving it than to leave it idling. If you need heat in the cab and that's the only reason you're running the engine, you can use a fuel-fired heater system instead of idling. This type of heater is also will also keep the engine at full operating temperature, which the engine itself cannot do. The second biggest problem with operating a diesel is not operating at road speeds high enough to passively purge the ash buildup in the exhaust. If you don't achieve a road speed of at least 40 miles per hour for 40 minutes or more, you will never properly purge the exhaust. Likewise, you need high road speeds and time when the engine is going through an active regeneration. Failure to drive on highway frequently will end up costing you downtime and repair expenses to clean up the exhaust at the repair shop. And let me make one last statement. There is evidence that running biodiesel lessens the impact of ash clogging the system. And so if you can properly store and maintain biodiesel, supply of it may help reduce your after treatment issues. And so with that, I'll pass it back to Justin Nye, and I thank you.
Thank you, Peter. Now we're going to be transitioning to maintaining the diesel vehicles. So if your requirement led you to a diesel, or you already have a diesel fleet, you can expect some differences in maintaining the vehicles compared to other fuel types. One of the most obvious ones with diesel maintenance is the cost. Additionally, for the preventive maintenance, diesel engines do hold more oil. On the positive, this means you can have more miles between PM intervals. Downside is if you don't drive the vehicle as much, you're typically paying more per PM for the oil change. Another thing with the preventive maintenance, the fuel filters are regularly replaced on diesel vehicles. And the exhaust systems require regular maintenance, and we'll be highlighting the driver's responsibilities for that maintenance later in the brief. And then for the engine parts, typically these are higher cost and lower availability, which brings us into the point of vendor service. Currently, industry is experiencing a shortage of qualified diesel technicians, which adds to the downtime for vehicles and has led to higher hourly rates going back into cost. This may not affect all localities though. And diesels will also have additional or more extensive systems than other fuel types. Typically these are exhaust related, such as the EGR, exhaust gas recirculation. They tend to have the larger turbo systems, as well as the larger fuel filtration system. Additionally, you do have the diesel particulate filter, DPF, and the diesel exhaust fluid, DEF systems, which we'll be focusing on. And all of these systems, they're going to add to the maintenance and care of the vehicle, and they can also increase your downtime and cost if not properly taken care of. So we've already tossed around the term DPF a few times today, but a diesel particulate filter, or DPF, it's a filter that was added to a diesel vehicle diesel vehicles after a 2007 EPA ruling to lower carbon emissions from diesel vehicles. Essentially, it just traps and stores exhaust particulates, being the soot and the ash. And the soot captured by the diesel particulate filter system can be cleaned through a process called regeneration. This will be done routinely, and the driver will be involved in this process. Before we cover the types of regeneration, there are two key points, and Peter's already touched on this earlier today. The low speed usage will not produce the heat required to regenerate or burn off the soot. And once the DPF becomes clogged, it'll cause poor system performance and can even shut down the vehicle. This is caused by exhaust back pressure. The exhaust can't escape. This ends up lowering the power output, lowers your fuel efficiency, and also over time, if this is a recurring event, it can lead to additional wear and tear on parts. And to protect itself, the ECM will shut down the engine if the DPF becomes too clogged. So there are multiple types of regeneration. They all result in the same thing. The soot is burned off. As a note, there's also going to be ash that'll be trapped in the diesel particulate filter. This is the non-burnable material. Eventually, this is going to have to be removed from the DPF. It'll be physically cleaned. and OEMs generally put DPF maintenance at over 100,000 miles for ideal use. And when they're saying ideal use, they're talking about higher mileage applications. So our first step of regeneration and the preferred, it's going to be the passive regeneration. A simple definition of this, the vehicle's operation is producing enough heat for the chemical reaction to turn the soot into carbon dioxide to escape the filter. Most people simplify this more and just say you're burning off the soot. Benefits of a passive regeneration, there's no additional action by the driver, and it's more common for long haul, highway type driving, or driving with a heavy load for a prolonged duration. The vehicle's use case generates the heat to burn off the soot. Our next type of regeneration is called an active regeneration. This will occur when the engine is not creating the heat needed for passive regenerations. So to create the heat, fuel is injected into the exhaust stream to raise the temperature and burn off the soot. The vehicle's ECM will trigger the active regeneration based on the soot level in the DPF. Additionally, most ECMs also have some form of speed threshold to start an active regeneration. A common one for buses would be 40 miles per hour for the vehicle to start the active regeneration. And it's recommended to check the owner's manual to see the specific requirements for an active regeneration on your vehicle. From the driver's perspective, with both passive and active regenerations, those generally occur without their knowledge. On some vehicles, the driver may notice that during an active regeneration, a high exhaust temperature warning light turns on. And sometimes they also may notice for active regenerations the smell of burning rubber. And then if they're checking the MPG on the vehicle during active regenerations, there's generally a drop in MPG since the fuel is required to perform an active regen. And for vehicles that don't meet the conditions for passive or active regenerations, the vehicle may have the option to perform parked or manual regenerations. This feature is not available on all vehicles, or it may require selecting the option during the acquisition process. If your vehicle does allow for parked regenerations, this generally takes 20 to 60 minutes. It does vary depending on the soot level, and it also varies on how the parked regen is started. Some OEMs have a dash control. Sometimes the switch to start a parked regen is somewhere else on the vehicle. So again, you do have to check your owner's manual for performing a parked regeneration. And as a safety note, this applies to all types of regenerations. The regeneration produces a lot of heat, and when you have the vehicle parked to perform a parked regeneration, please make sure it's away from other vehicles, it's away from combustible material. It can cause fire or damage if things are behind the exhaust during the regeneration process. It does produce temperatures of around 1,000 degrees. And if regens are not being performed, dash notifications or warning lamps will notify the driver that a regen is required. And the driver will have the choice of either performing a parked regen if supported by the vehicle, or the driver will need to perform an active regeneration. This can be done by driving the vehicle out on a highway type environment. The parked regen should start around 40 miles per hour in most vehicles and takes 20 to 45 minutes to complete. And that'd be for the active regeneration. And our last option for regenerations and the least preferred is a forced regeneration, sometimes called a shop regen. It should only be used when all other forms of regeneration fail. Essentially, it's just a parked regen, but a shop technician uses a computer to force the regeneration process. You can expect costs of around $150 on average. Depending on locality, it may be twice this amount or more. And you also have to plan 45 to 90 minutes to perform for the technician to perform the forced regen. And usually the need for a forced regen is because the active and parked regens weren't being performed, causing the vehicle to go into limp mode, 5 miles per hour, or to shut down the engine due to how clogged the DPF became. And sometimes a forced regeneration will fail to clean the DPF. At this point, the DPF needs to be removed and either physically cleaned or replaced. And I guess I'm checking out one of the questions in the Q&A box. I'm going to answer that one live. The question was, what if special circumstances prevent diesel vehicles from being driven off base or at high speeds to clear the EGR? What can the customer do? We did answer that with our stationary or parked regens. The thing to ask there would be, when you're acquiring vehicles, is to check with your FSR to make sure you're selecting the proper option for the feature that allows for parked regens. That way you can just flip a switch and in 20-45 minutes the regen can be complete. So as we mentioned, dealing with regens, it is a driver responsibility. The driver will receive different warning and dash notifications when regenerations are required. And ignoring DPF regen warning lights, this will eventually result in downtime, possibly being towed to the shop, and possibly getting a new DPF filter or just getting it clean, which does result in costs. Just like with any other incident where drivers did not perform necessary actions for dash warning lights or other dash notifications, the charges incurred will be the financial responsibility of the leasing agency. So we encourage drivers to follow the regen warning lights if they get the light, do the parked regeneration, or if they have the option to drive it on the highway, do the active regeneration. And another addition to diesel vehicles to meet emissions requirements was the diesel exhaust fluid system, or DEF system. It's needed to break down NOx emissions in combination with the selective catalytic reduction SCR technology. The key points that fleet managers and drivers should know is that it should never come into contact with the diesel fuel. It has its own storage tank, and OEMs generally always label it with a blue filler cap. Just like in the picture to the right, the green cap is for the diesel, the blue cap is for the DEF. In the event that diesel or DEF are put in the wrong storage tank, drivers should not turn on the vehicle. Please call the MCC number on the back of the fuel card for assistance. Generally, if you mix up the DEF or the diesel, the fluids will need to be flushed from the vehicle. And drivers will purchase DEF for the vehicle, and they can do that at authorized maintenance vendors or from a fuel station. Some fuel stations sell it in gallon jugs, and some fuel stations also have an actual pump for DEF. Just a reminder, parts stores are not authorized for purchasing DEF, just part of GSA policy. And drivers may purchase a gallon jug of DEF for immediate use to keep in the vehicle. What that means is that drivers can buy what is needed based off their mission. It shouldn't be stockpiled, and drivers should not buy DEF for multiple vehicles with the same fuel card. In some locations, DEF may not be readily available. These are the cases where we'd recommend having a jug of DEF on hand, or for long haul as well. That'd be a good reason to have a spare gallon of DEF available. Just like with regens, DEF is driver managed. To an extent, you can plan it out. It's used in a ratio of 50 gallons of diesel to 1 gallon of DEF. Drivers will get warning lights for DEF events. So the first warning light's generally for low DEF, which will be around 10%. And then generally the next warning light will be for empty. At this point, the vehicle is forced into limp mode. This means 5 miles per hour. Some vehicles would actually just fully shut down the vehicle. And additionally, most vehicles will have some form of gauge or dash feature to check the DEF level. It does vary by vehicle. And a general best practice is to just top off DEF after every 2 to 3 refuels. So some of you have already mentioned in the Q&A, I haven't been able to see all the questions yet on having issues with the regenerations. One of the options that's used to help with dealing with regen issues is actually using biodiesel. Biodiesel reduces the particulate matter, so that means it reduces your regens as well. Other benefits of biodiesel, you get the AFV credit. It has the natural lubricity for engine care. And nowadays, almost all diesel vehicles are supported up to B20. If you do have older vehicles or you're unsure, please check your owner's manual for the percent of biodiesel that is supported by the OEM. That will not void the warranty. So there are benefits to biodiesel. Also just want to explain some of the issues that you may run into or that you have to work around. First one is going to be fuel stability. Biodiesel is less stable than diesel and gasoline. So it is not good for storage. Part of the issue is it's also known for trapping water, which can also lead to something like an algae buildup in the fuel lines. So generally, any storage longer than a month, recommend not using biodiesel. For cold temperatures, biodiesel does begin gelling at a higher temperature than diesel and gasoline, so it may not be the best choice in some locations during the winter, or you may need to have some form of mitigation like a heated garage. And this one's a minor point, but for maintenance, you're going to lose about 1/3 of the fuel filter life. But generally, replacing a fuel filter is a lot cheaper than dealing with regen issues. And for some locations, one of the issues may just be availability. In the resources side, we do have a link to the AFE fuel locator page. This can assist you in seeing if you do have B20 or higher percentage of biofuel available in your area. And just want to actually show the drop in particulate matter. What's common would be B20. B20 usually offers over a 10% drop in particulate matter. So that is a translation to less regen requirements. And generally, the higher the percent of biodiesel, the lower the particulate matter, so the less regen requirement that you're going to have. And another way to mitigate DPF issues as well as just general diesel and fleet management is by using Telematics. The Geotab platform and devices which GSA fleet uses, they do offer tracking the diesel exhaust system. You can see everything from the DEF level. You can see the DPF warning lights. You can even actually see the soot level for the DPF. And you can also go and actually check the temperature of the exhaust and more features. And you can also look at the use case of your vehicles individually or for multiple vehicles at a time. Good examples are checking the percentage idling. They do have a speed profile, which can check vehicles individually to see if they're meeting the conditions for passive or active regions, or you can make other reports to check the average speed of the vehicles and the max speed to see if passive or active regenerations would work for the vehicle. And this could help you with a mitigation plan to decide if you do need to make sure that parked regen feature is available on your vehicles, or you'll have to have that duty cycle rotation plan to send them out on the highway to do the active regens. So we're going to try to do a quick demo. I'm going to pull up the MyGeotab platform. Maybe just a second to start the demo. And it is actually already up. So if you've never seen it before, this is the MyGeotab platform. This is going to be a very quick demo. It's not actual training really on the platform. We're just going to show you what you can see for the diesel vehicles, and then a few things that you can do to help with the management. So we're going to be looking at engine and maintenance first. That's the engine icon. From here, we're going to look at the measurements. That way we can see things like the actual DEF level %. We can also see things like the idle time as well. So we're going to go to yesterday. So just to show all the, or most of the diesel diagnostics available, I'm just going to type in diesel in the search window, and I'm going to select all. I'm also going to go back and add DEF as well. Then we're just going to select a few vehicles, which I know are diesels, to show these diagnostics. So this will take a moment to pull up. If you don't want to view things in the web browser, they do have reports available in Excel or PDF. And while this is loading, generally what I like to use the engine measurements for is just seeing which diagnostics are available on vehicles, and also to see what the data looks like. So to give you an example, we have the DEF level right here for this ambulance. We can check the diesel particulate filter regeneration status when it's going on and off. You can check whether it's doing active or passive regenerations. And there's also, on some vehicles, a diesel particulate filter trigger for regeneration if you actually want to try predicting when regenerations are going to occur. So once you know which data you're interested in, from here you can go to rules and groups, and then you can basically make triggers to notify you as the fleet manager that there's an issue with one of your vehicles, or that there's something that you need to look into. Some of the rules are already built in that'll help you manage diesel vehicles. If you scroll down to sustainability, they actually already have fleet idling rules. Peter brought up early in the brief that idling is not good on modern diesels. In this case, the rule is built in for 20 minutes, so you may want to drop that down to 5 minutes, and you can edit those rules. So we'll just say if you wanted to make a simple rule like a low DEF warning, you can go to the top, you click add, and then from here you have only 3 tabs that you have to work with. And let me see if I can zoom in. So name tag, you can just name your rule. Conditions, you have a lot of options here. You can add different engine diagnostics or faults to get warnings on. You can also add speed thresholds. You can go and you can add an and or logic to add in more features. So just to quickly make a DEF rule, we go to add engine. From here, when we're looking at engine and maintenance on those measurements, we're using the measurements, not the faults. And from here, we can just go to type DEF, which we used earlier, DEF level. And today we'll put under 20%. Click add. So anytime the vehicles on this database go under 20% for the DEF level, we can set it to get a notification under the notifications tab. So if you want to, depending on how serious the issue that you're working with, if you want to get a email notification every time a vehicle needs a regen, you do have that option, or every time a vehicle is low on DEF. So you can just type in your email and then you'd be good to go. Depending on how many vehicles you have, you probably won't want to get just an email for every single vehicle. So you can do the exception reports. The exception reports just let you know when rules break over a period of time. So if we want to see that low def idle shutdown timers, we could look over this month at our vehicles and we could see how often people were breaking an idle shut timer override rule and how often we had low def on our vehicles or how often active regenerations were occurring. And if you want to go more advanced, you can also go down to report setup and report views. From here, you can actually customize reports, any of those Excel files that you got from any of the other tabs on the menu. You can re-upload them after you format and add calculations with the Add Excel file. And from here, you can then, I'm going to use a previously made one, select where it shows up, if it's going to be on your dashboard. What many of you would be interested in probably is email report. And so you can actually set up this report to go to certain recipients or yourself. And you can set the date range for which data you're looking at. And then you can set up the refresh period, whether it's sent to you daily, weekly, monthly, quarterly. So that is an option. And I highly recommend, if you are interested in doing some of these things, Geotab does have a product guide, they have a blog, they have support resources as well. And I did want to answer, I think there's a question on the telematics. So yes, we did have the question, how do we get access to the My Geotab platform for our vehicles? It will be if you're paying the additional subscription, which you can do by vehicle. You don't necessarily have to do your entire fleet. If you want to just focus on your diesel vehicles, you can have just your diesels retrofitted, and then you can get access to the subscription with the data. And at the end of the brief, we will paste in more information on this. So we're going to head back to the slides. We did mention that with these slides, we do have a recommended driver's training document. It's a one-page checklist. We do encourage you to tailor it to your organization's needs. Please be aware, while we say it's a recommended driver's training document, the CDL requirement may be mandatory based off the gross vehicle weight ratio being over 26,000. Other cases where you may need the CDL are if the combined weight or if the trailer is more than 10,001 pounds, and then some states also the number of passengers that will be carried in the vehicle. So on the checklist, we do have the links to the state and the federal regulations to double check for some of the cases where you will need the CDL. Additionally, on that checklist and on this slide, we do have OEM training videos. OEMs do have videos on how to use their exhaust system, how to perform the parked regenerations, what the warning lamps look like for diesel issues. So those are available. So just to recap what we've covered today, you will see differences between other fuel types for diesels, particularly related to the exhaust system, the DPF, the DEF requirements. As mentioned, diesels do add driver responsibility, specifically the regenerations for the DPF system and managing the DEF fluid as well. Especially with the regen issues, this is preventable downtime and costs. And if you are in a case where you have that low speed and high idle, You may need to resolve this with the parked regions, which you may have to select the option during acquisition to have this feature. Other options are duty cycle rotation, sending some of the buses or trucks out onto the highway to be able to do the active regenerations. Other methods that you can track some of these features with telematics. And another option is to use biodiesel, since biodiesel can decrease the particulate matter requirement. And just to recap some of the points from earlier today from John and Peter, there are more gas options available for mediums and shuttle buses, and these may meet your requirements. But expect diesels to be here to stay. Gas is moving into some medium duty segments. EVs are moving into mediums, heavies, and buses as well. But diesels offer the torque and range, which will keep them a contender for mediums, heavies, and bus applications. For additional reading and research, we do have our resources here. They come from government, OEM, and industry, covering the dash warning lights, more information on DEF, calculating max payload and towing capacity, so multiple resources there for additional learning. So wanted to thank you for attending today's desktop workshop brief. It looks like we still have multiple questions to answer. So please continue to add your questions and we'll start going through them. Okay, I'm going to take this question live. The question was, because we rotate vehicles so frequently and we usually make money off the sales, is it not advantageous to buy a diesel? So with the diesel vehicles, generally there is a surcharge of around 8,000 to 10,000 just for the option for the diesel engine. At least for the medium duties, we recently did a case study, and generally based off the use cases, we do not sell the vehicles based off their mileage. Generally, they're sold based off the time and service, so the number of years. And so generally, we were not getting the returns that industry expected. Generally, diesels do return more, but in our case, the resale value was not as advantageous, which may be changing over time. I'm going to take a So I'm going to take this question live. Biodiesel, what is best, B20 or B15? I'd say if available, B20 is supported by almost all manufacturers. So I'd go with B20. That is going to produce less soot and ash over B15. And we did get asked about sharing the presentation. I'm going to paste the link in here. So both the slides and the recommended drivers checklist, those are available on the GSA training website. And Stacy, can you, so I guess Stephanie added on to the comment about the B20 versus B15. She did want to add in that B20 has less emissions than B15. And as I mentioned, B20 also is going to have less of the soot and ash produced, so less regen requirement slightly.
And Justin, that's a great point. And what I'll also add is that almost all of our diesel vehicles available, with the exception of the Sprinters or so, are B20 capable, so up to B20. Obviously B100, some of these fuels with a higher percentage of biodiesel, those are obviously, they have less emissions, but most vehicles aren't B100 capable. So just keep in mind that most of our vehicles are at least up to B20 capable.
And just a reminder, build on that, if you have the older vehicles, please double check your owner's manual to see if they support B20 or higher.
Great point, Justin.
So I'm going to toss this question out to John or Peter before I answer it. Your thoughts on winter storage of vehicles and fuel in them, fuel stabilizers and biocides, lubricity additives, cetane boosters in vehicles, and fuel storage tanks.
That's a lot of moving parts there. Peter, why don't you go ahead and take it if you want, that we could almost do a whole nother session on this one.
That's the truth. Some of the tricks you can use, I'll start with the DEF system. Frankly, because the DEF freezes at a fairly high temperature and doesn't tolerate heat over 75 degrees very well, it deteriorates very quickly. As far as the DEF system is concerned, you want to keep the tank as empty as possible. In the wintertime in particular, because it will draw electricity from your starting batteries in order to maintain temperature in the tank to keep it from turning into a big chunk of ice. DEF fluid, if you didn't know, is a mix of 2 to 1. It's 2 parts distilled water and 1 part urea. So in other words, the first component in your fertilizer for your lawn. So in liquid form, it doesn't have the ability to keep itself from freezing. So again, you're using the starting batteries to keep it from turning into a chunk of ice in the wintertime. So instead of using a lot of power, keep your DEF tank fairly empty. And then also in the summertime, if you're in the higher temperatures, again, if it sits out in the field and it's, typical days, 80, 90 degrees, you want to keep it fairly empty. So that way not as much of it goes bad, if it goes bad at all. As far as additives are concerned, there are, if you need an additive to keep your fuel from gelling in the wintertime, I use just white kerosene personally. I have a old piece of equipment, a 96 case backhoe, and it uses the old mechanical injection, and I have to use kerosene in that. Let's say I mix about a quarter of the volume is kerosene compared to diesel fuel in the super cold temperatures. So let's say below 10 degrees, going down into below 0, it is good to cut it with kerosene. There are some additives that you can add. If you have a vehicle that sits and idles a lot and there's really nothing you can do about it, there are some additives being sold, and I won't use anyone's name, but you can look it up on the internet and see what the comments are about it. That actually helps to keep from building up a lot of extra carbon around the injectors. And that's very critical on a diesel. So a little bit of additive in the wintertime is not a bad idea. In the summer, I want to say it depends on the person. Some people think that the extra additive will help the summer performance. It's mainly to keep the system clean. It's not really going to help your performance much. And I think that covers it, at least my part of it. I don't want to use brand names. I do use additives myself. I have a Nissan diesel pickup truck, uses a Cummins diesel, and I have the fortune of always driving it on the highway. It rarely ever is used in the city, but I still put additive in, and particularly before an oil change, to actually cleanse the injectors, cleanse the combustion chamber, and then of course I change the oil to get that stuff out of the crankcase as well. And that seems to be working for me. I've got 56,000 miles on the vehicle and 0 problems, never have a DEF issue. I go into active regeneration about every 1,000 miles, and the rest of it is all passive, and that seems to be fairly steady. But again, I've got the ideal situation. I'm either always dragging a 10,000 pound trailer, or I'm on the highway, or both. So it works out for me. But if you're idling a lot, yeah, you should use the additives. And also there are cleaning systems that can be used to help out the engine. You can, now this is when the engine's shut off, there are foams that can actually be injected into the intake system that actually cleans the EGR passages, which do get clogged up a lot on diesels that idle a lot. It also cleans out the intake. It will not go through the engine, but it actually goes through the exhaust system and basically cleans out the turbo and so forth. And that will actually help you find air leaks. Air leaks are a big problem with diesels in particular because you're disrupting the airflow in the intake system, which also affects how your DPF system is actually registering what's actually coming through the pipe. So yeah, it's a good way to go to clean it let's say every 30,000 miles or less. You can run this stuff through it. Again, I'm not going to use brand names, but it's a foamy stuff you can get that you can inject into your truck. And the repair shops have it a lot of times, and that's a real benefit for chronic, again, chronic idlers who have no choice. And I'll end with that.
Got another one that wanted to answer live, and I can answer this one if unless somebody else wants to grab this one. What effect does the different types of diesel fuel make on the ash and soot buildup? So
Justin, you want us to answer that, or you want to answer that?
I'll let Eric or Peter, do you want to answer this one? And if not, I can go for it.
Okay, well, this is Peter. It's my opinion that the higher the percentage of biodiesel you use, the cleaner the system will be over time. The drawback is you do lose torque, and if you put in too much, too rich of a value, there are lubricity issues, and so you can actually run the engine too dry, and that'll affect the injectors. But that's probably the best way to select the diesel fuel. As far as branding is concerned, what you get at the pump really doesn't matter. All of the fuel is transmitted through pipe. All of the fuel is brought to different places in the country based on the pipeline. And so at the fuel storage tanks local to your area, and let's say in the Washington area, we have one on Pickett Road in Fairfax, and we have another one in Baltimore, and then we have a third down in Springfield, Virginia. And all of the fuel, regardless of where it's what brand you're buying at the pump, is going to come through those tanks. The only difference in the fuel, and this includes gasoline too, is the additive package the manufacturer throws in the tank while the truck is being filled up. That's it. That's the only difference. So if you have and I did notice there is a slight difference for me, and I'm not going to use brand names because I shouldn't, but I did notice that one of them actually makes my truck run a little bit smoother. And I don't know if it's helping me as far as the particulate filter is concerned, but I don't go into regen quite as frequently. So I will say there is something there, and you should probably experiment a little bit with it to see which one works best for you. Oh, let me add, biodiesel is a big question, and in percentages, the manufacturers figure that that 20% biodiesel is a 5% dilution. So they figure they consider their use to be 100,000 plus miles per year. So on a truck, if you do less than 100,000 miles per year, they don't even think that's a normal use. Now, so that's across, obviously that's cross-country trucks. The Daimler, for example, for the longest time said that they would only approve 5% biodiesel because they didn't know what kind of wear and tear they would have on their injectors. After I convinced them that indeed our trucks never see that much mileage, they backed off, and now they're allowing 20%. But the reality is, with a little bit of research and a little bit of testing, you can go beyond 20%. You just have to watch to make sure you're not causing erosion problems of your fuel lines if they're made from a rubber compound, as well as you need to make sure that your tanks are clean, because it is an ester, and it will actually remove all of the garbage from your tank and put it into your fuel system. So, and that's what Justin was saying earlier, that you need to replace your filters a little bit more frequently, because yes, everything that is poor in that tank is going to end up in your fuel system and hopefully be caught by your filter. And I'll stop with that.
And I'll just add one quick note there. If you are a GSA leasing customer and you're interested in doing that on a leasing vehicle, please consult the owner's manual and your FSR if you're interested in trying to do more biofuel than recommended by the manufacturer. We have one more question, which John is going to help answer.
Okay, I'll just jump in there. I was typing it in. I think the question you're referring to is how often percentage-wise should a diesel vehicle be on the highway to effectively be worth an organization's time and effort? Unfortunately, the answer is probably it depends. It's going to depend on, and I don't know if you mean the highway versus, say, back roads versus on a small campus when it's, you know, traveling from one bus stop to another. I would think that probably at least 50% of the time, or really substantially more, open road would make sense. But I don't know that we can quantify that very effectively. If you're not really on the open road, you're, you know, that much of the mission, you're probably not putting enough miles on there to save the fuel and take advantage of the efficiency and the increased life expectancy of the diesel either. So I would probably say about half the time, but that's my opinion, and depending on what it does, we'd have to really look at the big picture. And you could reach out to us offline. We'd be more than happy to look at the individual situation.
So we did hit 12 o'clock, and other presenters will still be on here for a bit longer if there are questions.
So thanks, guys, and thank you everyone who attended. Lots of great information. We had lots of great detailed questions coming in too. As with just about anything GSA fleet related, you know, if you have questions, please feel free to reach out to your FSR. They're usually a great first stop for any and all questions. If they don't have the answer, they will definitely be able to put you in touch with somebody who can. All right, I don't see any new questions coming in. So with that, I think we're going to wrap it up. Again, thank you everyone for attending, and thank you to all of our awesome presenters today. Have a great day.
Thank you very much for your time.
Bye, everybody.